Hello everyone, welcome to appendix section. In this section, what I'm going to do is that I'll be covering the services that are essential for data engineering and also for the services that the course covers. We need to know what are the basic AWS services are, like EC2, networking, etc. This appendix is mainly useful for the people who have no experience in cloud and AWS. So if you have experience in cloud and AWS, you can actually skip all the entire appendix section, or only can look at the videos which are relevant for you. So if you do not know, let's say VPC, you can look at the VPC videos. But if you know AWS cloud, most likely that you would be knowing EC2, VPC, IAM, etc. And you can skip those sections if you feel so. This is going to be the first chapter in appendix. Basically, this is appendix 1 and the name of the chapter is EC2 and EBS. Here, I'm going to cover EC2, which is Elastic Compute Cloud, and EBS, which is Elastic Block Store. This is going to be our agenda. I'll give you an introduction of cloud as a whole and then what AWS is about. Then I'll go into EC2 and finally to EBS. So what are the prerequisites you need? So basically an internet connection and a personal computer. That's all we need. And you have to open an AWS account. You can create a free tier account and then use that account to do all the exercises that we'll be doing in the appendix section and in the course also. So first of all, what is cloud? Now, before answering that question, let me ask you one question. What do we need for application software? Now when I ask you what do we need, I'm asking everything. Can you list down the requirements of an application software? So if you have to create a software and host on it, or basically publish it to, let's say, to the entire world, what are the things that will be needed so that the software goes to the entire world? So you can pause the video and take it and list down those things. All right, I hope you have done so. So if we take a backward approach, then let's start from the software itself. Okay, obviously you need to run the software, so you have to code the software also. And to run the software, we'll need a server. So to run the software, we need a compute, RAM, and maybe storage, because that's how every software runs. We need to run it in an operating system, and we would need some hardware like CPU and RAM, and the CPU will execute the instructions which are there in the software, which is written by any of the programming languages. And that is true for any software for that matter. It can be database software, file software, normal Java application, Python application, message broker like Kafka, data warehouse like Redshift, Snowflake, etc. It can be any application software. So you need compute and you need storage. Now in compute you have CPU and RAM, and in storage you have the disk. Now for CPU, RAM and disk, to have these things we need something called a server. So server is something which contains the CPU, RAM and storage, and the server should be placed somewhere. It's not that you can keep the server in your home. Of course you can do that, but if your application is pretty big and the application is for an organization, you cannot have a very small server at your home. It has to be in something called a data center. So data center is nothing but a place where you have multiple servers up and running. Now, to create a data center, of course, the cost is very high. So what you need to do is that you need to acquire a land, then you have to create buildings, place cooling systems, electricity, place physical security, software security, etc. So the cost of a data center is very high. So let's say I want to start a business, and no business can run without IT. So I need an IT application of the business. So for me, if I create a data center, that's a huge investment from my end. And if the business does not run, then the investment would completely go in vain. So the risk factor would be very high if I go and buy a data center. The cost would be millions of dollars, and maybe my business is very small. So it does not make any financial sense to do so. So instead of creating my own data center, I can use a data center from someone who maybe leases the data center on an hourly basis or on a per day basis. So that's what cloud does. Cloud provides data center on a pay-as-you-go model. So you use the data center and its corresponding services as long as you want, and we pay as per the utilization. So if you use it for 6 hours a day, we'll have to pay only for 6 hours a day, not for the entire month. Unlike data center, we'll have to make an upfront investment of millions of dollars. So cloud is basically, at a very high level, data center provided by other parties which are available over the internet. So it is made available to people over internet. So that's what cloud is. You have a data center and you make that data center available to people over internet. This is one of the simplest definitions that I can give you of cloud computing. So it's not only about data centers, there are a lot of other services also, meaning there can be database services, there can be big data services and data engineering services. As you might already know, we'll be talking about Athena, EMR, Redshift in this particular course, Hive in EMR rather. So all these are provided by AWS Cloud. So it's not only about providing data centers, it can be application softwares on top of data centers also. Now there are two form of clouds. One is public cloud and the other one is private cloud. So whenever we have these kind of setup wherein the entire infrastructure is provided to us over the internet, that is called a public cloud. And AWS, Azure, Google Cloud, all these are public cloud because we can access them from the internet. Now, remember, it does not mean that it is unsecure, that it does not mean that the cloud environment is unsecure. It is very, very secure. Customers store financial data in cloud also. It does that some of the services are made available to you so that you can work on it and make it secure. So what is AWS Cloud? It is a cloud service provided by Amazon Web Services, which is the full form of AWS. Now, when I say cloud service, there can be multiple services, as I said. Now, it's not only data center. So when I say cloud service, it does not mean AWS provides only data centers and we work on the data centers using the internet. There are services which are provided like database services, data engineering services like Spark on EMR, Glue, Redshift, Kinesis, S3, Kafka, etc. The starting point of AWS cloud has to be regions and then availability zones. So what is a region? Region is a geographical location which is span across entire globe. So for example, let's say North Virginia, that's a geographical location. Sydney is another geographical location which is a region in AWS. Mumbai is again a region and basically it's a geographical location. Availability zones or AZs are the data centers inside of those geographical locations or regions. So we have this region and each region has a region code. For example, I have mentioned region code as US East 1, which is the code for North Virginia. There are region codes for other geographical locations also. For example, for the region Mumbai, the region code is AP South 1. So each region has a region code, which is nothing but a geographical location, and inside of this region we can have multiple availability zones or AZs. Now each AZs are nothing but a logical data center. Why you call it a logical data center? Because actually each AZ contains multiple data centers. But we'll not go into that much of complexity. We'll remove that intricacies and we'll consider a single AZ as a single data center. Each region has at least 3 data centers or 3 AZs, and each AZ would have its own code also. For example, in US East 1 there are 6 AZs and the code is US East 1A, 1B, 1C, 1D, 1E and 1F. I'm showing you only 4 AZs here. But what I mean to say here is that each geographical location has multiple AZs which are separated by certain amount of distance. It's not that the AZs are just sitting next to each other. They are within 100 kilometers of range. And these AZs are connected to each other via high fiber channel. So the connectivity is very fast. It's not like internet connectivity. These are in multi-gigabits per second connectivity using fiber channels. Now this region and this AZ, which are the data centers, and we launch cloud services inside of these AZs or inside of these data centers. So now you understand that, let's say if you talk about AWS provides us these regions which are geographical locations. They have already created the data centers there. Now in case of US East 1, we have US East 1A, US East 1B, US East 1C, US East 1B and others, which are connected to each other using high fiber channel. So these are the various data centers that the region US East 1 or North Virginia has. And these data centers are made available to the public using internet so that we can start the cloud services. Now, as I say, cloud services can be a database service. It can be data engineering service like S3, Redshift, etc. But we'll be launching them inside of the AZs, which are inside of the regions. Before going further, let's explore AWS Cloud. So type aws.amazon.com and it will open this particular console. Then you'll have to sign in to the console. So you can only sign in to the console if you have already created AWS account. So I have already created AWS account and I'll be logging into it, and it would show me the landing page. So this is the landing page. Now it says console home and there are multiple AWS services available. It also talks about the applications that are there. Now before going into these details, let me show you the concept of region. So here if you see, we have North Virginia as the selected region, but if you click on this, there are so many other regions available. So we have US East 2, which is Ohio, then California, Oregon. In Asia Pacific we have Mumbai, Osaka, Seoul, so on and so forth. There are some regions which are not enabled for this account. Again, I do not need this, but just to show you, there are other regions in Africa, in Asia Pacific, in North America, that is Canada. In Europe also there are multiple regions, and in Middle East also there are multiple regions. So these are the various regions that are available. Now if you have to work on a region, what you have to do is that if you just click on it and then select the region there, and that's it. We have changed the region, we have changed the geographical location. Now any service that we launch now would be launched in the Mumbai region and in the AZs which are available in the Mumbai region, which we'll see shortly. We do not have any application as of now, but we can see how many AZs are there. So what you have to do if you want to take a look at the AZ, so you can go to the EC2 console. This is again one of the ways, and it will launch you the EC2 dashboard, or it will show you the EC2 dashboard, and here it will show you the zones, which are the zones available, right? So how many availability zones are there? So you have AP South 1A, AP South 1B and AP South 1C, and if you want you can enable additional zones or additional availability zones or AZs. Now AP South 1A is one AZ which is a physical data center. AP South 1B is the second AZ, which is another physical data center. So is AP South 1C. Now all these AZs and all these availability zones are part of Mumbai region or are in the geographical region location Mumbai. Similarly, if I click US East, which is North Virginia, and scroll down, it will show me the AZs which are available in North Virginia. So there are 6 AZs in North Virginia region. It is the only region where we have 6 AZs or 6 data centers. So as you can see, it starts from US East 1A and ends at US East 1F. So these are the various AZs available in North Virginia region. Similarly, if I let's say select Tokyo, which is a region in Japan, and scroll down, so Tokyo also has 3 AZs AP Northeast 1A, AP Northeast 1C, and AP Northeast 1D. These are the three data centers available for the region Tokyo, which is AP Northeast 1. For all the regions, we can enable additional zones also depending on whether it is allowed or not. It's not that for all the regions additional zones can be enabled, but these are the basic building blocks of AWS cloud. The regions, which are the geographical locations, and then the data centers inside of inside of those regions, which are called availability zones or AZs. So whenever we launch any service, we'll be launching those services inside of one or more data centers or AZs. Now, AWS global infrastructure has approximately 34 regions. So if you see here, the ones with the green dots are the regions which have already been launched, and the one with the blue dots are the regions which are coming soon. This is again as per the time of this recording, which is November 2024. So if you see, US has 6 regions. There are 2 regions in Canada. India has 2 regions. Japan has 2 regions. Australia has 2 regions. There's no region in New Zealand, but there's one coming up. So far, AWS has launched 34 regions, each with multiple availability zones. And if we add all the availability zones or all the AZs, there are approximately 108 AZs across all those 34 regions, which are the geographical locations. So now what are the cloud services do you launch inside of those regions or data centers or AZs? One of them is EC2, which is computing capacity on AWS cloud. So what is EC2? Before going into EC2, let me take a step back and understand what is a server. So as I already told you that server is a mixture of CPU and RAM and storage that the server already has. We consider storage as part of the server also. It's not only CPU and RAM. So EC2 is nothing but a virtual server that is given to us, and we can launch these servers using the console that I have just shown you. At a high level, this is how the architecture is. There are multiple hardwares available in AWS regions and data centers or AZs. On top of this hardware, there's a virtualization layer. Now, why virtualization layer? Because entire cloud runs on virtualizations. So that's why EC2 is a virtual server. It's not a physical server. Whatever service we launch, all those services are basically virtual services. Now, it does not mean that there's no physical presence of those servers. The word virtual is a little different here. It is not literal. It means it's a technology. It's a virtualization technology, which is also called hypervisor. So using that technology, the servers and other services are launched. It no way means that there is no physical presence of these servers or the services. Now on this virtualization layer, the virtual servers are launched, which is in our case is EC2. And then we can use these servers for any of our use cases, just like servers in the on-premise data centers or servers in your home also. Let's say we can create an application server, we can create a data server, we can create a Spark cluster. Now when I say cluster, cluster is a group of multiple servers. So this virtual server would be part of that Spark cluster. Similarly, Presto cluster, when I say cluster, cluster is a group of multiple servers. So if you have one virtual server, that can be a part of the Presto cluster. So we can create any server out of these virtual servers. Now, of course, there are multiple other things which are there in EC2 also. Let's dive a little deeper and try to understand what other components are available in EC2.